Okay, so this is the last video. Just to follow up what I just said in the previous video, just using a little diagram. There are words on there as well, which you can read in your own time, but I'm mostly referring to the diagram to help explain how a salt and a weak acid can have a buffering effect. So, first thing, you have your, my finger's going in the right place, you have your salt, sodium ethanoate. Because it is a salt with an Na+, it will completely dissolve, which gives you Na+ ions, which don't affect the pH, and ethanoate ions, okay? Now, your ethanoate ions are waiting for any added H+ to go in, and if it does, most of it will become ethanoic acid. So you use the conjugate base of a weak acid in salt form, so when H+ is added, it bonds with that conjugate base, keeping the pH the same. So you have lots of ethanoate in the solution. Further to that, you add ethanoic acid, which only partially dissociates into ethanoate and H+. If you add OH-, it bonds with this H+, but it will force more of this to become dissociated. As such, overall, you want your H+ amount to stay the same, and thus the pH stays the same. Now, there's obviously a limit to this effect. It won't buffer forever. You can add base and the pH will stay roughly the same. Maybe it will get a little bit higher, and you keep adding base, and eventually you'll use up all of the ethanoic acid which is in your solution, and the pH will go shoot up. On the other hand, if you add too much acid, too much H+, you bond with your CH3COO-, removing the H+ from the solution, so the pH stays roughly the same, maybe goes a little bit down, a little bit down. Once you've ran out of ethanoate ions, the pH will just go as you add acid.